Let's begin by reviewing our convection cup lab. In this lab, we looked at two different temperatures of water, hot water and cold water. When we placed the hot water in the small vial surrounded by room temperature water, we noticed that the hot water immediately began to rise up very quickly and float at the surface of the cup. We explained this by saying that the hot water was lighter or less dense. That's why it rose to the top. When we looked at cold water inside of the vial, cold water surrounded by room temperature water, we noticed that the cold water either stayed in the vial or it slowly began sinking to the very bottom of the cup. We explained this by saying that the cold water was heavier or more dense. Let's apply this to the concept of wind. Turn to page 9, titled Wind Basics. Okay, what is wind? Wind is caused by changes in air pressure. Air moves from areas of high pressure, we're going to look at what that means, to areas of low pressure, from high to low. Here's that vocab word, convection. Convection happens in the air, just like it happened in the convection cup lab where we use water, hot water, and cold water. Warm air particles have space to move around. They are less dense, so they rise. Cold air particles are packed tightly together. They are more dense, so they sink. Go ahead and grab a blue color and a red color. You're going to need both of those for the next part of our notes. I'm going to go ahead and start with my blue color, and I'm going to be on the left box here. I'm going to draw the letter H. What do you think H stands for? Good, high pressure. Why do you think we colored the H blue? What does the blue color tell us? Good, it is cold air. What does cold air do? Good, cold air sinks. And why does cold air sink? Good, because it's more dense. I'm going to draw a little box here. I want to talk about cold air for a second. Cold air. We have cold air particles, and those cold air particles tend to be packed very tightly together. So I'm going to draw in some cold air particles here with my blue color that are packed very tightly together. I'm going to make a little note here that says packed tight. When I think of this, I think of penguins huddling together. So I'm going to write penguins huddle together. Why do penguins huddle together? Yeah, because they're trying to stay warm. All of those penguins want to stand next to each other because they want to stay warm. Cold air particles are like penguins in that they like to be right next to each other. Because they're packed so tightly, they are heavier, so cold air sinks. Now let's switch to our red color. I'm going to switch to my red color, and I'm going to draw a big red L. What do you think L stands for? Awesome, low pressure. Why do you think we colored the L red? Great, yeah, it represents warm air. What does warm air do? Yeah, it rises. And why does warm air rise? Awesome, because it's less dense. Let's talk about warm air for a second. I'm going to grab my red color. Warm air has a lot of space in between the particles. There's a whole lot of space. So warm air particles, they like to be spread out. They like to be spread out. It's kind of like when you've been outside on a really hot day and you've been running around all day. You feel really hot and you don't want anyone to touch you, right? You don't want to huddle together with a bunch of other people who've been outside all day. So this is like you're hot and you need your space. Warm air particles do not like to be close to one another. They like to be spread apart. So that's high pressure and low pressure. We're just looking at the temperature of air and what the particles are doing. Remember, cold air sinks because it's more dense, and warm air rises because it's less dense. Let's see how that would happen on Earth's surface. So I'm going to go to the bottom of my page, and across the bottom, I'm going to write down Earth's surface. Earth's surface. I'm going to draw a little sun in the corner. Maybe it's a happy sun. What is the sun going to do to the Earth's surface? Excellent. It's going to heat the Earth's surface. It's hot. So now we've got this area here right at the Earth's surface. What do you think the air right there at that colored part, what do you think the air is going to feel like if the sun is beaten down on that part of Earth's surface? Yeah, that air is going to feel warm. This is hot air. What do we know hot air does? Good. Hot air begins to rise. It rises because it's less dense. Remember, the particles are really spread out. This is like low pressure. Once that air gets away from Earth's surface where it's being heated, what do you think it's going to do next? Yeah, it's actually going to start sinking down. This is our cool air. It cools off. It starts to sink because it's more dense. Remember, it's more dense because those particles are packed really tightly together. This would be high pressure. Sinking cold air. This whole process here of the hot rising and the cool sinking, this whole process is called convection. This is an important concept for us to realize. As the warm air starts to rise, the cool air comes in and it takes the place of the warm air. So the cool air starts to sink, it comes in and it takes the place of the warm air. This is where we see wind. So warm air rises and cool air sinks and takes its place. This is wind.